So we're solving this quadratic for our warm-up. We moved our 5x over to get it equal to 0. Jody, can you take off your hood, please?
No.
Alright, there shouldn't be a reason you should have it up. So x squared plus 5x plus 5. Once again, quadratic formula, we need to figure out that a, b, and c. We always have to find those three numbers. So what will my a be for this problem? B, and then c, also 5. So we have 1, 5, and 5. We don't care about the x squared. We don't care about the x. We just need those numbers. And from these numbers, we're going to plug them straight into our quadratic formula. It should be at the top of your paper if you need one that's easier to see. I know this up in the corner is not as nice. But we have the opposite of b, which is 5, plus or minus the square root of b squared, so 5 squared, minus 4 times a, which is 1, times c, which is 5, all over 2a, which is 2 times 1. Once again, so we're just taking those numbers, plugging them right back into that formula. We good so far?
Yep.
Oh, I'm sorry, I forgot the squared. So 5 squared, I'm sorry. So negative 5 plus or minus 5 square root of 5 squared minus 4 times 1 times 5, all divided by 2 times 1. What do we typically do first? Or what should we do first? Exponent. So we want to do the part that's under the square root, and we want to first focus on the exponent under there. So 5 squared will give me 125 minus 4 times 1 times 5. Now, as you get more familiar with this, you don't have to put every single step. You don't have to put this step and this step and this step. If you want to sort of combine these, if you know this is 5 squared, if you know how to already combine these, you can change that to one step and sort of condense it. That way you're not taking up a whole sheet of paper just for one problem. So if the more you start getting familiar with it, the easier it is to condense those steps. That can also be something you can start to do. But once you start getting familiar with the steps, of course. So now that we squared our 5, we're going to want to multiply this group of 3. So it's negative 4 times 1, negative 4, so minus 4, times 1 times 5. Sorry, not what I'm writing down. So negative 4 times 1 is negative 1, times 4, or times 5 is negative 20. Good. This bottom part, I can already multiply that because that's already 2 times 1. Are you okay with that, Dylan? Sorry, I was writing and talking about something else.
He was writing negative 5 and negative 12.
Okay, yeah, I'm sorry. Simplify what's under the square root. We always have to simplify that first before we can do anything outside of it, besides that denominator piece before it. So negative 5 plus or minus 25 minus 20, 5 over 2. And now here's where it gets fun. Do we have a square root of 5? No, at least not a perfect square root. And so at that point, we're going to have to pull out our calculator, plug in square root of 5, and look at what that number is. It should be like 0.237 something. So we're going to round that to, I'm sorry, I'm going to come back up here. Negative 5 plus or minus 0.24 over 2. So that square root of 5 doesn't have a perfect number. We're going to have to use those rounding. Typically rounded to decimal places, probably the nicest thing to go to. But if you really feel like going farther, you can. What comes next?
Don't you want to add that? That's my
We just split it into 2. So one of them we're going to add, one of them we're going to subtract. So one you'll do the plus, one you'll do the minus. So x equals negative 5 plus 2.24 over 2. And then x equals negative 5 minus 2.24 over 2. Probably easiest just use a calculator unless you're really good with decimals. X equals negative 5 plus 2.24 should be like 2.76 or negative 2.76 over 2. And then we can just divide that to get x equals negative 1.38. So once again, that's one solution. But because I also have a minus, I have a second solution too. So I subtract those two, I get x equals negative 7.24 divided by 2, and then we plug that into the calculator and divide that. So x equals negative 3.62. Do you have a question, Dylan?
Those two are the same idea.
So whenever we put that plus or minus, we always split into a plus for one of them and a minus for the other, and now we'll see how we change. Any other questions on any of the steps we did for this problem? I know we kind of zoomed through that one a little bit, but this was one of our problems we did yesterday at the end of class. Comparatively to the beginning of the week, how are we feeling at sort of scale 1 to 10 on quadratic formula? Like, just given a quadratic, you could solve it? Eight. Is that 2?
What?
Is that 2?
How are you bumped up?
Oh, 1 to 10.
7.5.
Okay. Okay. Just sort of. Okay, that's good. That's good. So tomorrow's gonna be a large day of just practicing using quadratic formula. We'll do a little bit of reviewing the factoring, solving by factoring as well. But once again, I just want you to have sort of a preference. I want you to just be given a quadratic. I want you to be able to solve it. If you prefer quadratic formula, go for it. If you prefer factoring, go for it. Once again, though, like we saw yesterday, not everything can be solved by factoring. We couldn't solve this one by factoring just because you get those ugly numbers in there. So we want to be comfortable with using both, just in case you get stuck. All right, so we're good with the front side. We're going to flip over to the back side of your paper. And then we're going to try to finish this today, and that's sort of where that's the goal for today. All right. Let's try to solve this quadratic. Using our quadratic formula, let's try to solve that. But I want you to sort of tell me the steps. What would you do? How would you walk through? So what should we do? ABC? Okay. A equals 3, B equals 2, C equals 2. Just pull those straight from the problem. We have our A, B, and our C. Now what? Alright, take my A, B, and C and just plug it right into that. Fill in all my A, B, C's in my quadratic formula. So X equals opposite of B plus or minus the square root B squared minus 4AC all over 2A. Cool? Okay. Good now. Okay, so we have our 2 squared with that exponent right there. So x equals negative 2 plus or minus the square root of 4. 2 squared is 4, minus 4 times 3 times 2, all over 2 times 3. Cool, cool. What now? So negative 4 times 3 times 2. I can multiply that whole chunk together. The negative 4 times 3 is negative 12, times 2 is negative 24. And I'm just going to multiply this on the bottom part, just because we can. 2 times 3 is 6.
Wow.
Okay, so far?
Yeah.
Now what? 4 minus 24. Sorry, 4 minus 20. What is 4 minus 24?
20.
Positive 20?
Negative 20.
Negative 20. Okay. Square root of negative 20. Someone do the square root of negative 20 for me. Negative. Square root of negative 20. Get a question. 3.
Can I borrow a calculator, please?
Sorry. Yeah. Grab a calculator if you want one. Who wants the calculator?
got it.
All right, square root of 20. Once again, on these calculators, to do the square root, it's second, then the x squared button. Square root of negative 20. For negative 20?
When I got error, negative 400.
Error?
Yeah.
What? Why is there an error?
Because you planned this square. There's no calculator saying of negative 20.
Yeah.
What do you mean there's no thing in negative 20? There has to be, right? There has to be a square root of everything. Sure. Why not? Why can't there be a square root of negative 20?
Because it's negative. It's impossible.
Why is that? Why is it negative?
Because math said no.
I got 400.
So, when we were squaring numbers, or when we were taking the square root of numbers, so if I took the square root of 25, we said in the past that this is either 5 or negative 5 gives me the square root of 25. And the reason, because a positive times a positive give me a positive. A negative times a negative give me a positive. How did I get a negative? So I need a positive and a negative. Are those the same numbers though? So you can't have two of the same numbers multiply and have a negative as their product. They can't be the same number. And so in this case, there is no square root of 20 or negative 20. There's just no number. Or at least in this case, no real number. And so at this point, if you have the square root of a negative number, there's no solution. There's no answer to this problem. You just can't go any farther. So at this point, you would just stop and say, no solution. So sometimes there aren't any x-intercepts. Sometimes you can't find any solution for it, or any real solution to be the correct way we'd say it. So no real solution, because we can talk about real numbers, and we'll dive deeper into that later in the year after our state test. But for right now, there's just no real solution for the thing. So earlier, I think it was last week, we talked about how quadratics could have multiple number of answers. Typically, we would get two answers. Sometimes we have two x-intercepts. Sometimes, like that last one, we have no solutions. And then other times, it's possible to get one solution. So sometimes you might have two x-intercepts, two answers. Sometimes you might get one x-intercept or one answer. And other times you might just get no x-intercepts. And that's fine. Because if we think about the shape of a quadratic, if this is my x-axis, our quadratic might dip down and cross that x-axis twice. That would give you two solutions. Our quadratic might dip down and just touch that x-axis at a single point. Just once. It bounces off the x-axis and then keeps going back up. That would give you one solution. And it's also possible for our quadratic that it just glides right over the x-axis and never touches it once, giving you no solution. So sometimes with solving these quadratic formulas, you might get one, you might get two, you might get none, and that's okay. It just really depends on how the quadratic is formed. And if you get an answer, if you get to a problem like that and you're like, oh, I have a square root of a negative, something you might do to check is grab one of those graphing calculators and plug it into the graphing calculator, and if you see the quadratic not touching the x-axis, if you see the quadratic looking like this, or looking down here and looking like this, then you're like, oh, that's why I have no solution. That makes sense. So that's another quick way to check, just to make sure you actually have the right number of answers to that solution. Are we okay on this? Any questions on this, on why we have multiple solutions and stuff like that? So once again, if you do run into that negative square root, just put no solutions or zero real solutions or something like that, and that's, you can just leave it at that. You don't have to keep going. You can't really do anything from there. So that's fine. And that's really what we're going to practice with today. or for the rest of today at least. So the rest of your paper, you should have 3 quadratics on your paper. Your goal is to try to start solving these and see how many solutions you get. Some of them might have 1 solution, some of them might have 2 solutions, some of them might not have any solutions. You shouldn't get 7. That would be something really weird. But you might get 1, 2, or even 0 solutions. So I want you to go through them, start solving them using your quadratic formula, and see how many solutions you end up with. And just keep practicing those quadratic formula skills. Sometimes you might have to take the square root of some ugly numbers, but once again, that's okay. We can deal with that. Okay, yeah. So I'm just going to keep walking around. If you get stuck on one of your problems or you get stuck on the quadratic, let me know, and I will answer. If you finish all 3 of them, let me know, and I can come up with an example for you.